Good day, everyone. I'm Jeremiah Nano, and today I'll be presenting a detailed comparison between a digital pressure sensor and a force sensing resistor, commonly known as FSR. In this presentation, I'll explain how each sensor works, how they are interfaced with Arduino, their advantages and limitations, and where each one is best applied in real-world engineering systems. I'll also discuss why choosing the correct sensor is important in system design, especially in terms of accuracy, cost, and reliability. Before going directly into the sensors, it's important to understand what we mean by pressure sensing. Pressure is defined as force applied per unit area. In engineering, measuring pressure accurately is essential in many systems, such as medical devices, industrial automation, robotics, and environmental monitoring. Sensors allow us to convert physical pressure into electric signals that can be processed by microcontrollers like Arduino. So let's start with the digital pressure sensor. So a digital pressure sensor measures pressure and provides a digital output, meaning the sensor itself handles signal amplification, filtering, and conversion. This is particularly useful in applications where accuracy and stability are critical because it reduces the amount of processing required by the microcontroller. Digital pressure sensors are typically based on MEMS technology, which stands for Micro Electromechanical Systems. MEMS allows very small mechanical structures to be integrated with electronic circuits on a single chip. Because of this, digital pressure sensors can be compact, energy efficient, and highly precise. Internally, a digital pressure sensor contains a microscopic diaphragm. When pressure is applied, this diaphragm bends slightly. This deformation changes the electrical properties of piezoresistive elements attached to it. These changes are then amplified and processed inside the sensor. When interfacing a digital pressure sensor with Arduino, we usually use I2C or SPI communication protocols. These protocols reduce wiring complexity and improve reliability. Since the data is already digital and calibrated, the Arduino code becomes simpler and more efficient. Because of their design, digital pressure sensors offer high accuracy, excellent repeatability, low sensitivity to noise, stability over temperature changes. These characteristics make them ideal for applications where precision cannot be compromised. Now that we've discussed digital pressure sensors, I'll be moving on to the force sensing resistor or FSR. Compared to digital pressure sensors, FSRs are much simpler devices and are often used in projects where precision is not the main concern. An FSR is a sensor whose resistance changes when force is applied. As force increases, resistance decreases. Unlike digital pressure sensors, FSRs provide an analog output and are not designed for precise pressure measurement. When force is applied to the FSR, the conductive particles inside the polymer move closer together. This creates more conductive paths, reducing resistance. The change in resistance is then converted into a voltage signal. Internally, FSR consists of conductive polymer layers, spacer layer, interdigitated electrodes. These layers interact mechanically when force is applied, changing the sensor's resistance. Interfacing an FSR with Arduino is very simple. It typically requires one analog input pin and a voltage divider circuit. This simplicity makes FSRs popular for beginners and also for rapid prototyping. The main advantages of FSRs include low cost, thin and flexible form factor, a lightweight design, and fast response time. These features make FSRs ideal for wearable and interactive systems. If we compare the two sensors, digital pressure sensors clearly perform better in terms of accuracy and reliability. FSRs, on the other hand, are simpler and cheaper, but less precise. So the choice really depends on the application. One of the biggest engineering decisions in balancing cost and performance. Digital pressure sensors cost more but deliver precision. FSRs are cheaper but offer limited accuracy. Engineers must choose based on project requirements. Pressure sensing started with mechanical gauges and gradually evolved into modern MEMS-based digital sensors. FSRs came from developments in polymer electronics. It became more common with the rise of Arduino-based projects. Arduino ecosystem accelerated adoption due to open source hardware. Digital pressure sensors work well when we need consistent and long-term measurements. FSRs are more efficient for simple, quick force detection, especially when cost is a concern. Digital pressure sensors are less affected by electrical noise because they transmit digital data. FSRs, on the other hand, are more sensitive to noise because they rely on analog voltage readings. This makes digital sensors more reliable in electrically noisy environments. In terms of power consumption, both sensors are relatively efficient. Digital pressure sensors consume moderate power due to internal processing. FSRs consume very little power, which is beneficial for battery-powered systems. Calibration is another key difference between the two sensors. Digital pressure sensors are usually factory calibrated, ensuring consistent output. FSRs require user calibration, often using multiple reference weights, and even then accuracy can vary over time. When selecting a sensor, engineers consider accuracy requirements, cost constraints, environmental conditions, and system complexity. There is no universally best sensor. Despite their advantages, digital pressure sensors also have limitations. They generally more expensive, slightly more complex to configure, and they are dependent on software libraries. Therefore, they may not be ideal for simple or low-cost projects. The same thing goes with FSRs. They also have several limitations, like nonlinear response, or poor repeatability, long-term drift, and the sensitivity to its environmental conditions. Because of this, FSRs are unsuitable for applications requiring precise measurements. There are case studies that have been done in using digital pressure sensors in FSRs. For example, in a medical ventilator, pressure must be monitored continuously and accurately. In this case, digital pressure sensor is clearly the better choice because accuracy and reliability are great. The other FSR was used in creating a robotic hand that is designed to detect grip force, so using sensors is often sufficient. Its goal is to know whether an object is being held, not measure exact pressure values. Digital pressure sensors are widely used in mechanical equipment like ventilators and blood pressure monitors, boiler stations and altimeters, industrial process control, automotive systems. In these applications, inaccurate readings could lead to system failure or safety risk. For FSRs, is using human machine interfaces, robotic grippers, light analysis, and touch sensitive devices. Looking ahead, sensor technology continues to improve. Digital sensors are becoming smaller and more affordable. Flexible sensors like FSRs are evolving for use in wearable and biomedical applications. To summarize, digital pressure sensors are accurate, stable, and reliable, while FSRs are simple, flexible, and low cost. Each sensor serves a different engineering purpose. Sensor selection depends entirely on application needs. Digital pressure sensors are best for precision-based systems, while FSRs are better for simple force detection. Understanding these differences allows engineers to design more effective systems. That is all from me. Thank you for listening and have a nice day.